This video is on solving for empirical and molecular formulas. In order for you to do well on this section, you do need to have your textbooks open. And I'm looking at page 246, sample problem L, M, and N. I will do these practice problems for you guys just so you guys have a better idea of what's going on. Okay, so in sample problem L on page 246, it says that quantitative analysis shows that a compound contains 32.38% sodium, 22.65% sulfur, and 44.9% oxygen. Find the empirical formula of the compound. All right, whenever we have these problems that lists 100% of the material in these percentage forms, we want to solve for the mass, or at least just change the percentages to mass or to grams. So what we're going to do is we're going to take, it says 32.38% sodium. We'll just say that's 32.38 grams of sodium. And then it lists 22.65% sulfur. So we'll go 22.65 grams of sulfur and 44.99 grams of oxygen. Okay, well, it's not fair to compare things on a mass-to-mass basis in chemistry because things don't combine by masses, they combine by moles. Or the simplified version of moles is by per atom. So things will combine in a one-to-one relationship, not a mass-to-mass relationship. Okay, so we need to take these numbers and convert them to moles. Okay, in order to do that, we need the molar mass of these things. Probably should stick with some sig figs here. Sulfur is 32.07. And oxygen is 16.00 grams. Okay, so converting these things, 32.38 grams of sodium divided by 23 gives us 1.408 moles of sodium. 22.65 divided by 32.07 gives us 0.7063. And 44.99 divided by 16 is 2.812. Okay, now, so the first step is always convert to moles. Okay, when solving for empirical formulas, which is what I'm doing right now, I probably should have prefaced this with that. Solving for empirical formulas in sample problem L, the first thing you should do is convert your starting materials to moles, always. The second step is to divide by the lowest value that you have of moles. So between 1.408, 0.7063, and 2.812, 0.7063 is the smallest. So I'm going to divide everything by 0.7063. That gives me roughly 2 moles of sodium, 1 mole of sulfur, and 4 moles of oxygen. And now we have enough information for us to write our empirical formula. So I notice that I have 2 NAs, a sulfur, and 4 oxygens. That's my empirical formula, sodium sulfate. That's it, okay? Let's try another one. Let's go to sample problem M at the top of page 247 in your textbook. It says analysis of a 10.15 gram sample of a compound known to contain only phosphorus and oxygen indicates a phosphorus content of 4.433 grams. What's the empirical formula of the compound? Well, I know a couple numbers. The first thing I'll do is I know that I have 4.433 grams of phosphorus. Okay? Now the other number is the complete sample. So I have 10.15 grams of the total amount. 4.433 is phosphorus. So it makes sense that the remainder should be oxygen. So I'm going to take 10.150 minus 4.433. This is the total. This is phosphorus. The remainder should be oxygen, which is 5.717. Okay? All right. Now, step one in the solving for empirical formulas, that's what kind of problem this is. What is the empirical formula of this compound is what the question asks. So I need to do step number one, and that is convert to moles. So oxygen is 16.00 grams of oxygen to 1 mole. And phosphorus is, I got to look that up, that is going to be 30.97. So when I divide out these two, I end up getting 0.1431. And I get 0.3573. Okay, now when I divide by the lowest, that's step two. Divide by the lowest, which is 0.1431. I end up getting 1 mole of phosphorus. And I end up getting 2.5 moles of oxygen. I just can't ignore that 2.5. So I end up with PO 2.5. Well, we know that you can have 2.5 moles of oxygen, but you can't have 2.5 atoms. So I got to do something. And the way that I take care of this and still get the lowest whole number ratio, which is what an empirical formula is anyway, is I'm going to double these. And that's my answer. That's the lowest whole number ratio that still retains the 1 to 2.5 ratio of moles. Okay? All right, last one that I'm going to do for you guys is going to be calculating the molecular formulas. Calculating molecular formulas we find on page 248 for sample problem N. It says in sample problem M, the empirical formula of a compound of phosphorus and oxygen was found to be P2O5. That's just what we did. Experimentation shows that the molar mass of the compound is 283.89. What is the compound's molecular formula? So this is a molecular formula problem. So I know a couple things, so let's write them down. I know the empirical formula is P2O5. And I know if I add up the molar mass of P2O5, so I have to add 2 phosphoruses to 5 oxygens, I know that it comes out to be 141.94. So that's 141.94 grams per mole. Now I don't know the molecular formula. So I have a question mark here. But the problem tells me I have 283.89 grams per mole. Okay, now all we have to do is look at this, and let me ask you 2 questions. How much bigger is this than this? And it turns out that it is 2 times bigger. So if this is 2 times bigger, then this better be 2 times bigger. So our answer is P4. That's double O 10. Okay, that's it. That's solving for empirical formulas and molecular formulas. The first 2 that I did were empirical formulas. The second one I did was molecular formulas, and they don't get any harder than that. So if you can figure those out, I think you got a good shot. All right, make sure you guys contact me if you have any questions.